two lines y equals x, so that's a nice straight line, and y equals 0.5x over the interval 0 to 6. So we still need the interval, and we have this beautiful diagram shown here. And the area that we're trying to find is this one. So we're trying to find the area between, so we're trying to find that orange area. That's what we're trying to find. All right, so let's leave calculus off the table for a second. Let's say I gave this to you in a problem set to do. How would you tackle it? It's nice because we got some right angle triangles there. We know we can use Pythagorean theorem. How would you guys tackle this?
Find the angle of the total, like A and B together.
Okay,
and
yeah.
And then find the area of B, and then we subtract
the
area of B from
Okay.
AB to get A.
So if we were just to math this out with like grade, I think this is a grade 10 question, right? We could probably do this in grade 10. We're gonna find the area of the, maybe I'll spell it out. Area of y equals x with the x-axis, right? Like, so we're finding the big area here, and then we're gonna find the area of B, and then we're just gonna subtract them. So I think this is a grade 10 question. We could probably do that easily. And then we're gonna subtract. Okay, so let's find it. Subtract area B. Okay, with all of our high school math, we don't even need to use Pythagoras. Sorry, I'm cramming that in there nice and small so we can actually do the integration. So did everybody get 9 for their area? Like if we did it, just basic stuff. So this is one that we could math out, no problem at all. But if you look at the second question, all of a sudden that one's a lot more difficult to do because it's curved lines. But let's do this one with integrals here. So what essentially you have to do is you have to do it twice and then subtract them. So you're going to do the integral of, I'm going to put area a plus b, and we know we're going from 0 to 6. So we have to do that, like, so you have to do them separately, just like we just did here, and then we're going to be subtracting the integral of 0 to 6 of the area of just b. Now, I'm writing that down because that's kind of the math that we did, but we got to put some formulas in here. So the area of AB is bounded by what? Yeah, so x dx minus the integral of, and the area of B is bounded by 5x, right? And it might be helpful to put brackets around these. Just, I like to put brackets around them so the x's and the d's don't kind of get lost to each other. So if we do this one, what's the integral? Thank you. I lost my words there for a second. What's that going to be? X squared over 2, 0 and 6. And this one is going to be, and it's written as 0.5. I'm going to change it into a fraction of 1/2 x. And then if we do that, when we integrate it, it will be x squared over 4. And if you just want to see that math on the side, I got 1/2 x, and so we are going to have x squared 1/2 divided by 2. And so if you do that division, that's going to give me the 1 over 4. So that's going there. All right, so let's see how much math we can do in our heads. What limit do we start with, upper or lower? Upper. So we're going to start with a 6. So 6 squared is 36 divided by 2, which is 18. 36 divided by 2. We subtract the lower limit, which is going to be 0. And then this one's going to be 36 divided by 4. And the lower limit's going to be 0. So we've got 18 minus 9, which gives us 9 units squared. I noticed on our quiz we were missing our units piece on it. I didn't really harp on it before, but we are talking about an area. So just keep that in mind when you're doing that. I didn't deduct anybody marks for that. I think we all kind of know what we're doing. So using our grade 10 math skills, we could have solved this. Using our calculus skills, we can solve it. And the idea is that you do it on something you know first to apply it to something more complex like this. Because this would require us to create those little rectangles and do that, and nobody's got time for that. Okay? So we're going to just simply do this one. So nice and easy. I'm going to show you a faster way to do it though. I'm going to show you
like quickies.
Okay. All right. Well, if the interval is the same on both of them, and we're differentiating the same variable, which we are on all of these, so that's, you can put them under the same integral sign. And we would only do that if they're on the same interval. And in most cases, this will be on this because we're looking for the area between two curves on the same domain. So we're just going to go ahead and we're going to simplify this. And so the x squareds go away, and then it's going to be 2. Because I have 1 subtract a -1. Just so we don't lose that in there. And then we're going to integrate it, so that's going to be 2x. I guess I don't have a denominator. Made room for a denominator, but I don't have a denominator. So upper limit will be 4, lower limit will be 0. So my area is 4 units squared. So that's a nice little feature. You can actually go ahead and it will work both ways, whether you do them separately like we did in this question, where we actually figured out each one, or if you simplify it first. If we went x minus 0.5x, we would have been left with what? A positive 0.5, and then a positive 0.5 x squared. Right? So we would do the differentiation on that. We would have got the exact same answer. So, just making things easier. Fast, fast, fast. So again, another thing, we can do them separately, or we can actually go ahead and subtract them before we do the integration to save ourselves some time. All right. Determine the area bounded by the lines x plus 1, y equals 2x, x equals -1, and x equals positive 1. All right, so where is all that jazz? Oops. Okay, we got to look at the interval. You got to decide which one's the upper function and which one's the lower function. So we've been given this, and we're going from
Wait, which page is this on?
the next page.
Oh, okay, never mind.
Was yours not in order, or are you okay? Okay. So we're going from -1 to +1. So which function is and when I'm talking about upper, I'm talking about the physical upper function. Which one is the top function? Which one's the top function? Y equals x plus 1 or 2x?
Y equals 2x.
But we're looking just over. We're looking in this area here.
X plus 1.
X plus 1. So this we've identified as our upper function. You need to know that because that's the function that's going to come first. So we look at the interval. And we have to identify, I don't know if there's a better way to say it, identify the upper function. I'm not saying the function that's greater. What I'm saying is the one, well, the y values are greater. The one that is physically higher than the other one. So we know on this one, we're saying y equals x plus 1 on this interval is above y equals 2x. Okay? Because the upper function and that might be like when we're doing the integral, we've decided we got to pick which function comes first, and it's purposeful. The bigger function, the larger y values, come before the one with the lower y values. If not, you'll end up with it backwards, and subtraction doesn't always mean it'll just be negative. So when we do this, when we do the integration, we're going from -1 to +1. And we are going to have upper function first. So x plus 1 subtract 2x. And I'm going to be honest with you, normally what I do every time is put the second one in brackets, because if there's more than one term, I'm going to have to distribute that negative, and that's a really easy mistake to make. Is everybody okay with my anti-differentiation there? We're all good? So we're going to evaluate our what limit first?
Upper limit?
Upper limit first. I like to say it out loud just so we can remember. So we're going to have -1 over 2 plus 1.
Yes.
Okay. And then subtract -1 over 2 minus 1. So that's still a negative because the negative is outside. Those are just some things that are really easy to mix up. We're going to have a +1/2.
Plus a negative 3/2.
Shouldn't I have add 3/2?
Oh, yes, add 3/2.
And so that'll give me a whopping, how many? 4 over 2. So my area is going to be 2 units squared. So nothing, I think that's the trickiest part of it, is just figuring out which one is your upper function. Okay. And then there's just some situations that are going to pop up that are just going to be different. So if you look on everything else that we've done, on this question, this graph, the lines intersect. I guess this one they didn't intersect on this one. So we have a situation here where the graphs don't cross. They're kind of separate from each other. So determine the area bounded by the graphs, the parabola and the linear over the interval 0 to 1. So you just treat it like you would again. Which one is the physical upper function?
Y equals 2x squared plus 2.
So the parabola is up top. Oops, sorry, I'm off the page there. So when we do the integral, so 0, 1, we're going to start with the 2x squared plus 2, and we're subtracting the linear function. So just know that you'll see them and they might touch, they might not touch. If they touch, like in the next example, we're gonna have to figure out what to do with that. Okay, so we got to
So
answer
this is
different.
upper subtract lower.
Always upper subtract lower. Yep. Always upper subtract lower. Okay, I gotta anti-differentiate. So we're gonna have 2x cubed over 3 minus x squared over 2 plus 2x. What's the nice thing we know about the lower limit? It's 0. So at least we can do that in our head. So we're going to have, and the upper limit's positive 1, which is nice. So we're going to have 2/3 minus 1/2 plus 2 minus 0. I'm not even going to do the math on the lower limit. There's an x in everything, so I know that these are all going to be 0. So I'm not even, like, we don't have to show that. So what do we got there? Common denominator of 6. So we're going to have 4/6 minus 3/6 over 12/6. So our area is going to be 13/6 units squared. So nothing super difficult, just to keep in mind that the functions don't have to touch. There's no rule saying that they have to touch. All right, determine the area bounded by the graphs x plus 2 and negative x plus 3 over the intervals 0 and 3. I think we should graph these because it's going to show you something. If I put the graph there, it's for a reason, not just because I like graphing linear functions. Although it's a really good time graphing linear functions. Mm-hmm.
No.
What?
No.
What do you need? Was it because I wasn't on the screen? Was that it, or are you just saying that? So I'll stop asking? Okay, fair. Plus 2. I hope everybody feels confident graphing linear functions.
You taught us that really nice in grade 10.
I know, but
And
sometimes...
The textbook.
Was the textbook the best?
Yeah, the textbook, I practiced it so many times there.
And are you a smarter person because of it?
Yes.
Nice. And I'm bounded by 0, 0 to positive 3.
I remember the time when linear functions is like the hardest thing.
Mm-hmm.
Yeah.
Remember those days? Oh, good. Colored pencils. I got colored pencils. So this one is a little bit different. I'll let you guys catch up. Make sure that you've got your graph done. Okay, we're good? So this one's a little bit different in the fact that we're taking the area over a point of intersection. So it's not like a consistent distance between them. So we actually have to do this twice. We have to treat it like it's 2 intervals. We have a little tiny one right here. And I'm shading in pink. I don't know if you can see it. It's not a very... I was afraid if I used highlighters, I'd lose it. So I have that one there. And then take a teal, because that seems beautiful. And then we have this area over here. So we're gonna have to find the area between the two.
Stopping at 3?
What does the, what's over the interval?
Oh, okay, 0 to 3.
So we kind of have 2 parts to this. Not kind of, we definitely do. We've got these 2 parts, and mostly the reason why we're flipping is because if we look at the green area, y equals x plus 2 is the upper function. But if we pop over to the pink area, now the negative x plus 3 is the upper function. So where the point, because we change lines, we have to do this twice. And then we're just going to take our 2 areas at the end, and we're going to add them together. So just know that we're doing it because the upper function changes sometime in that interval. This one's really nice. Is it really nice? Not really, because what point is that? Because I need to know my interval now. But not a problem, we're good mathematicians. What do we know? Solve both equations. We're going to solve a system here, right? Because we know that the y values are exactly the same at that point. So we have to find this point of intersection first before we can do any integration, because we need to know the new boundaries. So point So I'm going to take negative x plus 3. I'm going to set it equal to x plus 2 because they are both equal to the same y value at that time. So I'm going to have 2x equals 1. So x is equal to 1/2. Do I need to know the y value? No, because I'm looking just for the domain. So I know the domain that goes from 1/2 to 3, the upper function is what? Which one? So if we're going from here to 3, so I'm in the green area here. X plus 2. And I know going from 0 to 1/2, I know the upper function is y equals negative x plus 3. So I had to break it down because my upper functions changed. So now essentially we're just going to break this out and we are going to go from there. Actually, you know what? I made a notation error, guys. This should be a round bracket. It can't be included in both places, so that should be a round bracket, not a square bracket. Okay, do you guys want to do the first one? I'll do the second one. You know what? Because I took the one with the 0 in it. It's who I am, it's what I do. Are you guys, make sure your dx is always showing up in there because you need to tell what you're differentiating or anti-differentiating off of. It's really easy to lose it. Oh, I missed a step. I missed a step, guys. Don't copy my math. I don't know if it's going to dry in time. Anybody see what I did wrong? I was differentiating or anti-differentiating with respects to the x-axis, not... I missed a whole step left unsupervised. This is terrible whiteout. You guys are working diligently over there and I'm just making mistakes. Oh, okay. Did you guys get 6.25 for yours?
I got 27 over 4, 6.75.
Oh, I'm not done. Did you do the whole thing? I got 6.25. You might want to double check your math there. Whew, it's a mess. It's really hard to read. Okay, so one side is 6.25, and then the other side is a half. So the total area is going to be those two added together. Yep.
Isn't that 0.5
instead of 1/2?
Oh, you were absolutely correct. Sorry. So I wrote it here. I wrote 2.5, but then my math didn't show it on the other side. So 6.5 is our total number. Okay, we've got two more examples to get through. It's a little bit of a long lesson. I just want to show you some strategies. Like there's different kinds of questions that you might get. This one, it says determine the area bounded by the graphs a parabola and a linear again, but there's no interval given. So if no interval is given, find the points of intersection. Now, over the points of intersection, now this one's nice and easy. It's given on the graph. We can still find it. This one's nice and easy. Let's find the points of intersection first. So we've got x squared minus 1 equals 2x minus 1. So it's going to be 2x minus, or x squared minus 2x equals 0. So our interval is 0 to 2, which was indicated on the graph. Like you could have easily picked it off the graph if you wanted to. This is how you would do it, just solve the system. So over that interval 0 to 2, there's only one upper function. It doesn't switch or anything like that, so we don't have to do it multiple times. Which one's the physically higher graph on that interval?
The 2x minus 1.
The linear one is. So that's just, there's nothing real different with the math that we're about to do. It was this part that was different. No interval was given. So find your points of intersection. So 0, 2, we've got 2x minus 1, subtract x squared minus 1. Oh, I'm sorry. I just got doing math there. Awesome, thanks. Nice one again. We've got x's everywhere. I didn't show my 2 divided by 2. I just canceled that out in my head if everybody's okay with that. And the lower limit's nice. It's 0.
Fractions are so much nicer here than this.
I agree. It's so much nicer when you don't have to use your calculator. I mean, I think it's like a security blanket, like it's nice to have, but I think we do better math without it. Okay, determine the area bounded by these two graphs. Again, no interval was given, so we have to find the interval.
Upper function of the y equals 16 root x.
We're not there yet. We got to find our interval before we do that. So we're just going to solve the system. We're going to solve the points of intersection. And this one has a radical in it. No big deal. So I've got 2x squared equals 16 root x. What am I going to do? Square both sides, right? Oh yeah, you could cancel 2 out. Maybe that might be better first. So I'd have x squared. So I'm just dividing both sides by 2. Would be 8 root x. Maybe make it a little smaller, so a little nicer when we go to square it. So I've got x to the exponent 4, and I have 64x on this side. So the easiest way to do this would be, so x is going to be equal to 0, and then I've got x cubed minus 64. Anything about 64 leap off the page at you? Nice. And if we cube root both sides, we're going to get x equals, and it has to be a positive 4 when it's an odd root, right? Because it's a positive.
Positive or negative?
Nope.
Oh, positive.
Right? Has to be positive because with odd roots, it is what it is. Okay, so my interval, again, we could have looked at the graph and seen this. I'm just trying to show you a strategy to use if you don't have the pretty picture to go with it. So we know our interval is over 0 to 4 again. Not again. The other one was 0 to 2. Nice thing about this is the upper function on that interval stays consistent. So it's 1, which one's on top? 16 root x, and I'm going to switch that to 16 x to the exponent 1/2. I think that'll just be easier when we anti-derive, and then the other one is minus 2x squared. Now normally we could combine like things, we could make it easier. This one is what it is. It's not great, but it is what it is. It's not friendly. Not friendly at all.
One of those, it's like Mr. Gallo.
Okay, so we've got 16x to the exponent 3 over 2 all over 3 over 2 minus 2 cubed divided by 3. I think I did that right. It's a lot of mental math. Multiply by the reciprocal here, so I'm going to multiply by 2, divide by 3. You okay? Well, thank goodness we have a lower limit of 0. When we substitute 4 in, oh, am I off the page? Sorry, I have a tendency to do that. And I know my lower limit is 0, so a couple of quick things. We know that this means a square root. Square root of 4 is 2. 2 cubed is 8. So we have 32 times 8 divided by 2. Oh, divided by 3, sorry. Divided by 3. And then on this side, 4 cubed is 64. Divided by 3. Hey, look, they have same denominators. That's kind of good. 256 over 3 minus 128 over 3. And I believe my answer is 128. 128 over 3 units squared. So just a couple of things there. No interval stated. Find the points of intersection. Make sure that your upper function stays consistent. If I were to give you one that switched, like the x, the two linears, I'd ask you to graph it first. If I'm asking you to graph it, chances are there's something on the graph you need to see. I'm gonna lead you there first. Whew, long last lesson.